By the end of this video, you should be able to explain the basicity of amines, i.e. how basic or how alkaline amines are, and describe the reaction of amines with acids. So amines are compounds, organic compounds that is, containing nitrogen, really. So, one we've met before, ammonia, and that's ammonia, and then an amine is if we have an R group attached to the nitrogen. So we've got two hydrogens, one nitrogen, and that is a primary amine. And you can have a secondary amine, which looks a bit like this. So we have two R group attached, that's a secondary amine, and then we can do a tertiary amine, and you can probably guess what this will look like. So note the difference between primary, secondary and tertiary amines and primary, secondary and tertiary alcohols. In alcohol, it's the OH bonded to the carbon, and then it's how many bonds to carbon that carbon has, whereas for amines, it's just how many bonds to an R group the nitrogen has. Okay, amines very common in nature. You'll recognise some of these names as I say them. So amphetamine is one. So amphetamines, the stimulant drugs, are all amines. And that looks like this. And adrenaline, another stimulant. Not named, or adrenaline doesn't sound like an amine name, unlike amphetamine. But if we had the very systematic scientific name, it would probably have amine in there somewhere. Okay? So naming amines is something we're going to have to do, and I'll talk you through that. So how we name amines is you look at the chain, that is the R group, and then you have your amine, your NH2 section there, and this is then propyl amine. Okay, so propyl amine, so not propamine, like you might expect, but propyl amine. If we look at some other examples, this where we have a 3-carbon chain coming off and a 1-carbon chain, we say this is N-methyl, and that tells us we have a methyl side chain and it's on the nitrogen. So this one here is N-methyl, and then propyl, that's the longest carbon chain, amine. Okay, and then we can have another one. 4. And this, because we have two propyl groups coming off the N, this is, sorry, I need to change stick in green. This is NN dipropyl, and then longest chain there, butyl amine. Okay, so a little bit tricky naming amines, but not too different to things we've seen before. It's got a lot of similarities. You know, your longest carbon chain. The only difference really is linking the side chain to the N and making sure we include that. Okay, so amines are weak bases. at next. So their basicity. So basicity, a bit like the word alkalinity. So amines are weak bases. And this is because they have a lone pair. So on the nitrogen there's a lone pair, and they can accept an H+. So for instance, if we take ammonia, a simple example, add H+, and then we form a dative covalent bond, and we form our NH4 plus ion. Okay, but we could just as easily do it with another of our amines. So we take ethyl amine and NH2. Okay, so I haven't drawn in our dative covalent bond there, but this is an ammonium ion, and we should be vaguely familiar with this. And then this compound here is an ethyl ammonium ion. Okay, so you can see from the name ethyl amine, the ethyl ammonium ion. Okay, so they act as weak bases, and then doing this they can react with acids. So amines can react with acids. But unlike other bases or alkalis, we'll say, unlike other bases or alkalis, they form only a salt. Okay, so if you react an amine with an acid, you don't get a salt plus water, you get just a salt. Okay, so let's have a look at a couple of examples. So let's do ethyl ammonium again, and this is aqueous, and we're going to have aqueous HCl, and you can pick up, imagine if you've got your ethyl ammonium ion forming, sorry, I just realised something. This here should be NH3 plus. Okay, sorry about that. So imagine you're forming so that's NH3 plus there. So imagine here we've got H plus. If that forms an NH3 plus ion, we've also got a Cl minus floating around in solution, and that's going to be attracted to that. So you get NH3 plus on the end, and then the Cl minus pairing up with that. Okay, and that is ethyl ammonium chloride. Okay, and then we'll have a look at another example with a different amine and a different acid. Let's move that up a little bit. So this is phenylamine and nitric acid. And again, we can think of our amine group picking up the extra hydrogen and forming this group, and then go, all right, what's our negative ion? What's left over? We've got NO3 minus. So this is phenyl ammonium nitrate. Okay, so amines are bases. They react with acids to form only a salt. They have a slightly funny way of naming them, but it should be pretty straightforward, and just got to be careful with the difference between how we do primary, secondary, tertiary amines and primary, secondary, tertiary alcohols.